Geometry with Mrs. Berry. This is lesson 61. Today we will be talking about circles and the Pythagorean theorem. So in chapter 6, we studied a number of properties that involved right angles in and around circles. Now we will use those conjectures along with the Pythagorean theorem to solve some more challenging problems. But first, let's review two important conjectures from chapter 6. The tangent conjecture. A tangent to a circle is perpendicular to the radius drawn to the point of tangency. And what about an angle inscribed in a semicircle? Angles inscribed in a semicircle are what kind of angles? They're right angles. Remember that an inscribed angle will measure half of the arc. If a semicircle is 180 degrees of an arc, then the inscribed angle must be half of 180 or 90 degrees. So here again is our tangent line, and the radius at the point of tangency is 90 degrees. And here we have a diameter or a semicircle right here, which also makes this side a semicircle. And the inscribed angle here that comes to either side of the diameter is going to make a 90-degree angle. So let's look at our first example. Ray TA is tangent to circle N at point A. TA measures 12 square roots of 3 centimeters. Now we have to find the area of the shaded region inside of the circle. So first I'm going to take this apart and draw just the triangle. Because this is TA and it is tangent to the radius AN, we know that that's a radius because N is the center of the circle, then I know that this is 90 degrees. So right here on my diagram, that's 90 degrees. Angle T is labeled as 30 degrees. And then it tells us that TA is 12 square roots of 3. If this is 90 and this is 30, then I know that this is 60 degrees. So I have a 30, 60, 90 triangle. The ratios of a 30, 60, 90 triangle would be x square roots of 3, and 2x. X being this small side, x square roots of 3 being the longer leg, and then 2x being our hypotenuse. If this TA is 12 square roots of 3, and that is equal to x square roots of 3, then I know that x must be 12. So down here, this short leg is 12 centimeters. And I don't even need to know the hypotenuse. However, I would know that it's 2 times 12, which is 24. But I need the area of the shaded region, so I need to know the area of the circle minus this arc. So again, this arc was 60 degrees. So the rest of the circle that is shaded must be 300 degrees. So the fraction of the circle that is shaded is 300 over 360. Now I multiply the fraction that is shaded times the area of the circle, area being pi r squared. I have pi, and what is my r? Remember that AN was the radius of a circle, and that was right here on our triangle, and that was 12 centimeters. So the radius of our circle is 12 centimeters, so I have 12 squared, or 12 centimeters squared. So 30 over 36, I'm just going to reduce that fraction. 300 over 360. I can reduce it by a power of 10 to make it 30 over 36. I can then divide by 6 and make that 5 over 6. I'll keep my pi, and I have a 12 and then another 12. Why did I write it this way? Because I want to cancel 12 with the 6 and leave it as 2. Now I have 5 times 2, which is 10, times 12, which is 120, times pi. And I was in centimeters. This right here would have been 12 centimeters and 12 centimeters, so that makes this centimeters squared. So 120 pi centimeters squared would be my exact answer. If I want to put it into my calculator and do 120 times 3.14159, I would get 376.991, or approximately 377 centimeters squared as the area of that shaded region. Now let's look at a second example. AB is 6 centimeters and BC is 8 centimeters. Find the area of the circle. So how do we do that? I'm going to redraw triangle ABC. Know that this is 8 and this is 6 and this is 90 degrees, so I can use Pythagorean theorem. 6 squared plus 8 squared equals AC squared. 36 plus 64. This is 100. And then to find out AC by itself, I'm going to take the square root. So I have 10 is equal to AC. I now know that this is 10 centimeters. And then how does that help me finding the area of the circle? Well, I look here, AC in the circle is inscribed from ABC. ABC is 90 degrees. So AC must be the diameter. So if AC is 10, 10 is my diameter, that means that my radius is half of that, or 5 centimeters. Now I can take the area of a circle is pi r squared. This is the area of the circle. I'm trying to find all of it. So I have pi times 5 centimeters squared, or 25 pi centimeters squared. And again, if I want to put 25 times pi into my calculator, I would get that that's approximately 78.5 centimeters squared. You see how knowing the connections between right angles in our circles helps us to form right triangles that can help us to find the dimensions that aren't listed.